Hi everyone. So let us solve one more question that was asked in GATE 2019 in Electronics and Communication paper. And this question was from MOSFET again. Once you will find this question, to see, you will find that this question looks quite big, okay? But the solution of this question is going to be very small, right? So the way I'm going to solve this question, okay, that you have to observe. And though you will be able to solve this question by yourself, but I just want to show you how Dheeraj sir uses his 11 plus year of experience to solve this kind of question, right? So let us try to see the question first. So this question was asked for 2 mark, okay, in GATE 2019 Electronics and Communication paper. And you can see they have given some sort of current mirror, right? Okay, using MOSFETs, okay? So in the circuit shown, V1 is equal to 0 and V2 equal to VDD. Okay, so they have made your life much simpler by giving these conditions, okay? The other relevant parameters are mentioned in the figures. Relevant parameters means they will help you to find the answer, okay? And the relevant parameters are nothing but these aspect ratio W by L, W by L, okay? You can see for all the transistors, they have mentioned W by L ratio and they are different, okay? And we know that the current in case of MOSFET is always proportional to W by L, okay? That you should always know that the drain current in case of any MOSFET, okay, is always proportional to W by L, okay, whether the transistor is in saturation or in linear, right? But we have to make sure that, these transistors, we have to consider that these transistors are in saturation, okay? You can consider like this, since it is a current mirror circuit, if you notice this circuit, bottom circuit, so it is a current mirror circuit, okay? So this current is going to get reflected in this you can say here, this 1 milliampere current is going to get reflected here, okay? So how much current is going to be this? Let's say that if W by L ratio is same, all the relevant parameters are same for both the transistors, okay, transistor parameters are matching, the same current is going to flow through right side of the transistor, but W by L ratio is different. Okay, so this current is going to be scaled by what? W by L, you can say this, okay, W by L equal to 3 by 2, okay? So your current is going to scaled by W by L, okay? The ratio of W by L, you can say. So here this current is going to flow through this, MOSFET, that is nothing but 1 milliampere is here. So 1 milliampere into W by L of this transistor and W by L of this transistor. So it will be nothing but 3 by 2, which is 1.5 milliampere. Okay. So you should be able to find this current by inspection. Okay. Always take, whenever you're trying to find the current through this right hand side transistor, in case of current mirror, the first transistor is in saturation because it is diode connected transistor. Okay. The drain and the gates are sorted, okay? So you should always consider that the current this transistor is in saturation, left side of the, okay, transistor, MOS transistor, okay? So the current is going to be flowing through this transistor, okay, that has W by L, which is 3, is going to be 1.5 milliampere. But now they have given some condition, V1 is equal to 0. So as long as this V1 is going to be 0 and this V2 is going to be VDD, keep in mind this, your this wherever V1 is connected, this transistor is going to be off. The moment this transistor is off, the current flowing through this transistor is going to be 0, right? So no current is going to flow through this transistor, 0 ampere current. So where does this current go? Okay, where does this current flow? 1.5 milliampere. This current is going to flow through this transistor, these two transistors, you can say, right? That is 1.5 milliampere, right? But now you have to find this current through the transistor which is having W by L ratio, which is 40. Again, this is a current mirror circuit only, guys. But they have designed this current mirror circuit, okay? That is nothing but a current source only, right? Current mirror circuit is a current source, okay? A good current source, you can say. In entire analog circuit, we try to, design a good current source. I think you guys might have watched my playlist and might have seen that Dheeraj sir always emphasize on building good current sources. Okay, that's they should mimic the property of ideal current source. Okay, so this is a current mirror circuit using pMOS transistors. So 1.5 milliampere is flowing. Okay, so you have to find the current through this transistor which is having W by L ratio 40. So again you can say that this I out is going to be equal to 1.5 milliampere into, you can't say the 1.5 milliampere is only the answer, okay, because they have different W by L ratios, okay, they have different aspect ratio, okay. So because of this different W by L ratio, you can say here 40, so you write 40 upon this transistor, that is W by L ratio 10. So what is 1.5 milliampere into 4, okay, which is nothing but you can say that 6 milliampere. So answer for this question is going to be 6 milliampere. And you have to answer this question up to one decimal place. So you can say 6.0 milliampere. Okay. So you see how simple this question was. It looks horrible. Okay. Okay. But if you have, attended my classes, if you have watched, if you got a chance to watch my playlist, you will be able to solve this kind of question. So how I'm saying that this current is going to get scaled by the ratio of W by L, let me tell you. Let's say that ID is proportional to W by L, right? So let's say you want to find ID2 by ID1. So it is going to be W by L2 by W by L1, right? So if you know this current ID1, so you can find ID2, right? So always remember this is nothing but a direct proportion concept, okay, in aptitude. How do we compute if something is directly related, okay? So if something is given, we can find something, right, by just taking the ratio, okay. So answer for this question is going to be 6 milliampere, okay, and you have to answer 6. So I hope this solution you have understood. We will come up with another video, okay, and as I promised that in this Diwali I'm gonna share all the PYQ solution, okay, using my learning by doing, learning by teaching experience of 12 year, right? So you're going to get advantage, right? So please do share this session among everyone, and if you're new to this channel, you can subscribe also, okay. That is not going to penalize you for anything. Thank you, keep learning.